My name is Robert Allred. In 1979, I founded a water treatment company based on the desire to provide consistent and professional service to users of water treatment in the western United States. We named the company Alpine Technical Services, and we have been providing that service to a variety of clients ever since. In the last several years, all of us in the West and in other parts of the world have become aware that water must be conserved if we are to continue to prosper and grow in any of our homes and businesses. State-of-the-art water treatment can assist in this effort. Recently, we became aware of a new technology that was developed in another country that has had to deal with water shortages for many years. El-Gharisi Engineering Services in Israel has provided equipment for the control of corrosion in cooling water for a number of years. Using their considerable experience in this area, they pursued a means of removing dissolved solids from cooling water. Their successful efforts led to the installation of a large number of units in Israel, which are saving millions of gallons of water each year. This technology is now available in the United States. Please pay close attention to this presentation and observe how water consumption can be reduced at your place of business.
A piece of Israel has come to Utah to help save our water.
For the past couple of months, a device Israeli researchers developed has been up and running in a Utah hospital. Ed Yates takes a look.
If you're a scientist living in Israel, there's a mandate. Invent new technologies to curb the wasting of water. The climate there and here share many similarities. That's why engineers at Utah Valley Regional Medical Center in Provo decided they would try a new device which promises to save up to 20,000 gallons of water per day.
EST sent out memos to all engineering to look at ways that we could save water in the forthcoming years. When this technology came back, and one of the main parts of it is how much water it saved, we looked at it.
What's really amazing about this new technology from Israel, partly, is its size. This is it, about 4 feet by 3 feet, and this little unit does it all and more. From the hospital's 2 huge cooling towers on the roof, this little device below, through a process called electrolysis, continually pumps, sweeps, and wipes away deposits left behind through evaporation. The tower waters are flushed only once every 4 hours and for only 3 minutes at a time. That means instead of water down the drain the old way 48 times a day for 12 hours, now it's down to 6 times a day for a total of only 18 minutes.
To my understanding, we're the first hospital in the United States to use this.
In addition to saving more than 2.5 million gallons of water per year, the hospital is also spending $600 less per month to lease the new system. Plus, the cooling towers on the roof are cleaner now than they've ever been before. Ed Yates, Eyewitness News, Provo.
And in Israel, the water-saving device is not only used for cooling towers, but to purify water in some of the smaller communities.
A new state-of-the-art water treatment system at the Salt Palace will save 1.5 million gallons of water every year.
The filter collects minerals in the water that would have otherwise built up in the used pipes.
Here's how it works. The Salt Palace cooling system uses cold water running through chillers over and over again. But with hard water running through the pipes, the buildup of solids in the cooling towers must be continually removed by flushing water through the pipes.
This is a process that uses about 8,000 gallons of water a day. Instead, what they have now was developed in Israel, and it uses electrolysis to remove mineral deposits.
The process, it's no longer required that large volumes of water be wasted to maintain the mineral balance within a cooling system.
By the way, the system was developed in Israel, and the Salt Palace is the second building in the U.S. to use it.
El-Gharisi Engineering Services Limited presents EST plus L, a computerized electrolysis system for scale precipitation and removal and prevention of silica crystallization. Water, a precious life-giving resource, once abundantly provided by nature. But in today's world, the supply of water is dwindling, and even worse, its quality is deteriorating rapidly. Conserving water and maintaining its quality is of paramount importance, vital to our survival. To supply modern diverse water needs, water has to be transported through complex pipeline systems and installations. Water flowing through these systems often leads to corrosion and accumulation of scale on their internal surfaces, resulting in energy losses, accelerated wear of equipment, and high maintenance costs. Customary scale treatment methods employ various water softeners and chemicals that contaminate groundwater and impair environmental quality. Water treatment is our expertise. EST plus L, the electrolytic system developed by El Gharisi Company, is the most advanced solution for scale prevention. The patented system has been approved for treatment of drinking water by the Israeli Ministry of Health. Some 1,000 electrolytic systems for protection against corrosion and scale have already been installed. El Gharisi systems have proven effective in hotels, industrial plants, communal settlements, office buildings, shopping malls, army camps, hospitals, universities, and many other institutions throughout Israel. Kibbutz Mishmar HaEmek has been suffering for many years from rapid accumulation of scale on various flow and heating surfaces due to the high carbonate content of the water pumped from its wells. To solve the problem, El Gharisi Company installed 3 parallel EST plus L scale prevention systems on the main pipeline supplying this veteran communal settlement with water. At Plasson, one of the largest and leading plastic injection molding plants in Israel, El Gharisi Company installed an EST plus L scale prevention system for the industrial cooling systems at the plant that prevents scale formation in the pipes and water ducts in the injection molds and arrests development of algae on their surfaces. At the large Dizengoff Center Mall in Tel Aviv, the company installed an EST plus L system attached to the storage tanks of 2 air conditioning cooling towers. This circulation system prevents accumulation of scale in the cooling towers, heat exchangers, and other devices in the condensed water path, as well as development of bacteria and algae, thus substantially reducing water consumption by the air conditioning system. The EST plus L system is composed of a separate reaction chamber, anodes specially developed for the electrolytic process that do not dissolve in the water, do not contaminate the water, and function for many years without needing replacement. Computerized electronic supply for continuous control and monitoring of the electrolytic process and system operation. Piston-actuated scale wiper removes scale from the chamber walls. Electrode for measuring electrical resistance of the water and softening scale by electric shock. Ball valve at the inlet to the chamber, and a drain ball valve at its bottom. Electrolytic plus L system for preventing crystallization of scale and silica. Water that enters the reaction chamber contains various ions and carbonates. Application of a strong electrical current initiates the electrolysis process that causes oxidation in the vicinity of the anode and creates an alkaline environment with elevated pH levels in the vicinity of the chamber walls that act as the cathode. The electrical current in the electrolysis system donates electrons to the water molecules adjoining the chamber walls that act as the cathode, causing the pH to rise to a level of 13 and hydrogen to be expelled. A computer continuously monitors this pH level in order to avoid reversing the polarity of the system, which causes corrosion. The cathodic reaction is written as the rising accumulation of the various carbonates on the chamber walls causes a rise in the electrical resistance and impedes the electrical current. To prevent this and to maintain the efficiency of the electrolysis process, the EST+L system continuously measures and monitors the electrical resistance in order to determine the appropriate time for wiping off the scale from the chamber walls. The cycle of wiping the scale off the chamber walls begins by first closing the water inlet valve and then opening the drainage valve at the bottom of the chamber. The piston-actuated scale wiper then moves downward, removing the scale from the chamber wall and flushing it down the drain. The inlet valve is then opened again, and the chamber is rinsed, the drainage valve is closed, the wiper returns to its place, and the system is ready to resume the electrolysis operation. Water molecules donate electrons to the anode and cause it to be oxidized. In the course of the oxidation process, pH levels near the anode drop and oxygen is expelled. Here is the chemical formula of the anodic reaction. Another important reaction that takes place in the EST system converts chlorides into chlorine. This action both manufactures disinfectant and also reduces the amount of corrosive chlorides in the water. This reaction is written as follows. In water systems with high level of silica, such as in cooling towers, it is recommended that the EST system be equipped with the electrolysis plus L system, which prevents crystallization of silica and the scale remaining in the water. Silica originates in dust from the air that settles in the cooling towers, and together with calcium in the water, forms hard, insoluble sediment that clogs the pipes. The plus L system employs a special electrode that releases into the water flowing through it highly soluble metal ions with strong positive charges, which prevent crystallization of silica and scale in the water. As a non-chemical, non-corrosive, non-polluting water treatment, the technology developed by the company is unique and environment-friendly. Elgarisi Engineering Services Limited is committed to saving water, preserving the environment, reducing costs.
We were very impressed with this approach and have made arrangements to represent this equipment here in the West. There are several systems up and running now, and they are performing as represented. Please provide the ATS sales engineer with the information that he needs, and he will provide you with an accurate computer model of the amount of water that you will save. You will also be pleased to find that there is a significant savings in operating cost from the first day that this equipment is put in service. We look forward to working with you.